Okay, we're live. Good morning. Welcome to CS-030. We are broadcasting here from Winter Hall. We've got like 3 different audiences right now. We've got you guys here in the classroom, and we've got the other people that are enrolled in the class that are remote, including someone from South Africa. And so I've asked Lisa to just monitor our Slack channel for us to see if we get any questions that come in. It's hard for me to keep track of all the different inputs that are coming through, so that would be great if she could do that for us. And then our last audience is, of course, just sort of the general public, who I don't know if they're going to be watching it or not, but I guess we'll find out 5 weeks from now. All right, so let's see. Let's try and just roll in with our first guy here. All right, and let's see. If all goes well. Be here. It should be now. Like, we just went live. So can you watch for me and see if they still think it's live? Not live? Who's texting you? Okay. So there's a little bit of a delay on the YouTube. So we'll see. Okay. Great. All right. So welcome, CS-030, kicking it off. I think there's always going to be a little bit of glitchy stuff like this, and hopefully we'll get better over time, but this is how we're rolling for now. So let's just arrive. I want to open in prayer. This is something that's a little bit weird maybe for people that aren't part of Westmont, but obviously we take the things that we do, our spiritual life and our intellectual life are very integrated, and that's different from what other people do, I suppose, but we're going to go ahead and embrace that, not try and keep them in separate spheres. So if you guys would turn off your notifications and cell phones for the duration, and then also just join me. I'm going to read a prayer that was passed around by the faculty to get our semester going. It says, "O Lord, grant me to greet the coming day in peace. Help me in all things to rely on your holy will. In every hour of the day, reveal your will to me. Bless my dealings with all who surround me. Teach me to treat all that comes to me throughout the day with peace of soul and with firm conviction that your will governs all. In all my deeds and words, guide my thoughts and feelings. In unforeseen events, let me not forget that all are redeemed by you. Teach me to act firmly and wisely without embittering and embarrassing others. Give me the strength to bear the fatigue of the coming day with all that it shall bring. Direct my will, teach me to pray, and you yourself pray in me. The glory of the Father, the Son, and the Holy Spirit, now and ever, and to ages of ages. Amen." Great. So, of course, now more than ever, of course, technology and programming is interacting with everything that we do, and so all the different facets of our life should be brought to bear on it. I think that's really important. Even though we're recording, you guys should feel free to ask questions if you want. That's a little weird, but okay. So just administratively, this is part of our Mayterm class. This seminar in particular is part of a five-week class, and today's lecture is scheduled for 2 hours. And if there is some kind of technical failure, particularly for the people that are watching remotely, please let us know via the Slack channel or whatever messaging you guys have with other people in the class. I'm actually not good enough yet to monitor Slack at the same time as everything else that's going on up here. So I'm relying on my 4 stalwarts here to help me out if that happens. If there is a technical failure, we'll try and kick over to a recording here, and we'll post the recording later. See how that goes. Okay, so the structure of the class, you guys are here, you're in person. This is a simultaneous remote and in-class offering. It's being broadcast live on YouTube Live, but there's a little bit of a delay. So people that are remote are seeing it like 15 seconds later, and that's to help deal with buffering and glitches and network along the way, so they get a good audio and visual. You guys are welcome to attend either, and you're welcome to mix and match as well. So my intention is to just be down here, and it's a lot easier to do lectures if there are actually people in the room, but I've done them with no one in the room, so we can do that too. I better get my Slack skills ready to go if we're going to do that, because otherwise it'll be you guys wondering what's going on. You can attend either, and you can mix and match. And I guess it's helpful if you let me know which one you're going to do, but it doesn't have to be anything formal. The other thing that I hope to do is I hope to do a few of these classes from Westmont downtown and sort of set up something like this downtown, which is on State Street. And so you guys would encourage you to come down with me, and or just that day do it remote if you want. The logistics of that might turn out to be a little bit hairy, but we'll see how that. Right. So some of the implications of broadcasting on YouTube, just so we're aware, is that this is clearly going on YouTube, and so there might be some incidental interaction that you guys have that ends up on YouTube. But my intention is not to ever video the folks that are in the room. You guys, it's not your like. I don't want to expose you necessarily. I also intend to only use your first names just because this is going to be publicish. If you ask questions, then that's going to be captured. And so if you're uncomfortable with that, let's talk about that afterwards. But what we are going to do is periodically when we're doing assessments, we're going to keep the stream running, but I'm going to shut down audio in the room so that in those assessments we can, if you're uncomfortable with that for whatever reason, we can ask questions along those lines. I set up a separate Slack channel for folks that are enrolled in the class called #broadcastquestions. And that's specifically the place that I'll monitor when I get good enough at it for things that are happening live, as opposed to the other channels, which can be used for other things. But all the course material is going to be on Canvas. So even the YouTube live links are going to be linked out from Canvas. So there'll be all these third-party things going on, Slack and YouTube Live, but Canvas is the place where it's all going to be organized. I think that the Canvas course is public to the world, but the assessments aren't. So people can see the contents of it, but they're not going to be able to see. They're not going to be able to take the assessments. I think that's the way it's set up. Okay. What's next? So we are going, like I said, we're going to periodically stop the videos so that people that are in the room or people that are remote can do an assessment of whatever we just talked about. Assessments just might be a little bit of practice exercise. Give us a little bit of break as well. Of course, the people that are watching remotely have the DVR magic, so they can pause and catch up or whatever they need to do along the lines. So. All right, so along those lines, I have a media release that's on Canvas. That's like a quiz. And so what we'll do is for our first assessment here, I will we'll take a few-minute pause and let you guys do that. So I'm going to turn off the audio. Test, 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 test. Okay. And we're broadcasting live. All right, so Boaz asked a question. He said, what did I think about the Facebook stuff? Sorry, Tim asked a question. Too many things going on. Keep me honest. What did I think about the Facebook stuff recently? And I guess my take on it is that Facebook has been pretty public about what they do with their data. You know, they've never been lying about the data that they've been collecting. And anytime you sign up for stuff, it's always sort of clear what you've been signing up for. It's just no one really understood the implications of that or really thought it was a big deal. And I honestly kind of think the only reason people cared is because a political campaign started using it. And I think that like it just happened to be that a political campaign decided to use that data, and now everyone's kind of it understands the reality of the impact of what that means in terms of the ability for a political campaign to target individuals based on their likes and dislikes. I was reading. Yeah, so the EU has much stronger data privacy rules than the US does, and because these companies are global, they tend to have to build in the protections for being able to work in the EU, even if they don't apply necessarily in the US. So they're not super duper stringent, but they're more protective of individual privacy rights than in the US. I would have to look into the details, but for example, you have more say over how your information gets shared and how far it can get shared, and more control over deleting it, and a couple of and about the ability for it to be transferred around to different parties, things like that. I kind of think the root thing of it, though, is really that the amount of money that's involved in campaigns. That if there wasn't so much money in campaigns, then there wouldn't be that much value on this data, and people wouldn't be spending so much time trying to collect it for political purposes anyway. So I kind of think the root is campaign finance reform, not really so much data privacy issues. But that's kind of my soapbox. All right, let's see. Good. So that was our first assessment, and let's see if all goes well. We should see. Go and shrink me down. Okay. So that was our first assessment. Completed the media release. That seemed to work okay, I think. So let me introduce me a little bit. Some of you guys have had class with me, but not everyone. So I'm going to kick over to a different slide deck. Actually, let's give you my story a little bit. That's from last class. So I'm married and I have 4 kids. So this is my wife and I going on date night, although that's not where we were living when we first got here. That was successful. Another successful date night. We like our date nights. This is my family. Oops, we had we were a little bit obsessed with boba last summer, so we were down at 805 Boba until we realized that there were other places to get boba in town, and you know, some of us were busy calculating how many different combinations of drinks you could get, like combinatorics, and others of us were just trying to get colorful ones or whatever. So anyway, we had a good time doing that. Theo is my tallest. Julius is my oldest. Joy is my oldest daughter, and Martha is my youngest daughter. Julius is adopted, and he joined our family last, although he is the oldest. So we got very complicated heights and ages and whatnot. The younger 3 live with me. Julius is living on his own down in Orange County now, going to school. Let's see what else is going on. Theo's at the Museum of Natural History doing some work there, getting ready to go to college. Joy likes sailing. That's her thing. Martha's out picking flowers sometimes. That's at Figueroa Mountain. If you've ever been there, just gorgeous. Like when the poppies are blooming, the entire side of the mountain is completely orange. You can see it from, yeah, it's right up in Los Olivos. Yeah, you can see it from you can see it kind of in the upper left there, the poppies blooming on the mountains. It's just kind of amazing. That's poop emoji hat. We also have a dog. Dog's name is Dodger. If you ever see me walking with him, he is my buddy, but he's not super friendly. So he stays on a short leash and doesn't get to play with other dogs as a result. But he's fun. And then I live in Las Broncos over in faculty housing. It's gorgeous. And of course, just like everyone else, we just suffered through all the fires, which were pretty intense and came very close to our house. We could see the fire, at least the firefighters could see the fires from our house. And so that was scary, to say the least. KEYT, the local news organization that has come to Chapel a couple times and whatnot. At one point, they were broadcasting on the top of East Mountain Drive, the fire coming down, and you could see our house over their shoulder in the background. It was, So professionally, I got my Bachelor's of Science from Cornell University. I was in the Naval ROTC program when I was there, and stayed and got a Master's of Engineering in Electrical Engineering. I was the strike officer on the Curtis Wilbur DDG 54 out of Japan, and I had a chance when General Hayden came last semester? Got to talk a little bit about what that was like. It was interesting. And then I was the operations officer on the USS Simon Lake, stationed in Italy. It was good too. I did a deployment to the Persian Gulf on both of those ships. And then I went back and got a PhD in computer science and engineering at University of Washington. Was the director for the Laboratory for Ubiquitous Computing and Interaction at UC Irvine, where I was for 10 years before coming here. I've been involved in a bunch of startups, mostly famous for their logos, which I seem to have an affinity for. None of them have made money yet. I don't know if you know the statistic, but it's like 1 in 10 startups actually makes money. So given that I've done 5 so far, I've got 5 more to go before one hits. So it'll work out. And then came to Westmont in 2015, and we sort of started the Westmont Inspired Computing Lab, which some of the graphics are here. And actually, hey, news, that organization is going to be transforming a little bit to the Center for Technology, Creativity, and the Moral Imagination. And that's going to be trying to work some facilities in Westmont downtown. So we're going to see if we can put together kind of an incubator, kind of a maker space, but also a business plan competition, and some mentoring with local business folks. So if you want to do a startup, we might have the infrastructure for that soon. So excited about that. All right, so that's me. So the next thing to do is on Canvas is a get to know you quiz. And so this is something I ask all my students to do at the beginning of the semester so that I can find out a little bit about where you guys are coming from. Some of the questions, some of you may have completed before, but some of them change over time as well. So what we'll do is we'll take a break here for a second and give you a chance to fill that out and let our friends at home fill it out as well. And we'll pick up in maybe about 5 minutes. Audio's on, and we've got the background screen now, and paste down there at the bottom. Great. All right, so that gave you a chance to do the Get to Know You quiz. All the assessments that we're doing today are going to be due this evening, and you can, if you need to follow up on them or redo them for some reason, you can do that after class today. And let's see. Okay, so the next thing that we need to do is we need to go over the syllabus on Canvas, and this is a little bit dry, but it's kind of the policies that we need to run through in order to make sure that we're all ready to go. It's not just a little bit dry, it's very dry, but it's important to talk about. And so the assessment for this is we're going to stop halfway through and trying to work with Canvas, Canvas a little bit on that. Okay, so let's see. Let's go over to our Canvas installation. There we go. And if we take a look at our structures and policies, first of all, you're in CS-030. Great. What is this course about? Well, it's primarily about computer science. It's the second course in computer science. So we expect people in this class to have taken some kind of programming class already. Usually that's our CS10, our Python class. So I'm going to have a lot of assumptions that you guys have seen things like lists and objects before. And what we're going to try and focus on in this class are the bigger picture issues around computer science that have to do with data types and abstract data types. Things like lists, stacks, queues, maps, trees, graphs. But in order to get there, we have to also learn about Java along the way, because we have to know the syntax of the language that we're working with. And some of the issues around searching and sorting, speed and efficiency that we saw in CS10 are still applicable in Java, so we'll look at some of that as well. And then some of the discipline of professional software engineering that has to do primarily with software testing in this class. We'll take a look at that as well. And to some degree, we'll talk about ethical issues from the creation and use of computer programs, which we've already done a little bit. Okay, so that's where we are. The class meets Monday, Wednesday, Friday from 10:15 to 12:15. It's a pretty intense schedule. It's a lot. It's a fire hose. And it's going to take some time outside of class for you guys to process the reading in the book. The textbook's a really important part of the class as well. Yep. Okay, so we're in Winter 110 when we're on campus and in person. A lot of caveats there. Maybe Westmont downtown at some point. For add drop policies, we just use the normal add drop for timelines for class. And if someone for some reason wants to come and join later and needs prerequisites, you need to have your prerequisites. So that's just sort of standard. Office hours, because I'm doing 2 Mayterm classes, I don't have a really good slot for office hours, so we'll have to set it up by appointment. Hopefully we'll have time in class to work through some stuff as well. And then we can use the Slack channel also. But we'll play that by ear. My office is up in Winter Hall 310. You just want to do a drive-by and see if I'm in. Books. Our book is this book called Big Java Early Objects. It is, as far as I know, it's only in binder format. So if you want to like save the book, get a 3-ring binder and make sure you put it in quick before the pages get all over the place. I actually really like the book. I think it's a really nice overview. It's very similar to the Python book, except that it doesn't have a binding. In as much as it has a lot of the same kind of style and same layout. Have you guys picked it up? You can also get it. There's also an online version through. I have a program called Vital Source. It's like the publisher's e-textbook reader thing, and so that's kind of nice if you don't want to deal with the paper. I don't know if there's a Kindle version. Okay, so my general philosophy for class hasn't changed very much. The higher level principles that I'm trying to do is to juggle fairness, grace, and integrity. So fairness, making sure that everyone is doing the same amount of work for the same grade, but also so that I'm doing an appropriate amount of work also. So not being overburdened any more than the students are. Grace for a complicated world, meaning that stuff happens with sicknesses and incomplete sort of things, late homeworks. So there's some built-in capacity for turning things in late, missing things. So that's part of the class. And then integrity as well, which is making sure that the grades that I give you reflect actually the work that you did. So that's important also. Let's see. I tend to give a lot of different assignments rather than just a few big exams, especially in computer science. because of the fact that it is a practice, it's a skill in as much as it's a way of thinking. You just need a lot of working with the language and doing the programming, working with the IDEs and stuff. And so part of that is another reason why I do lots of little assignments along the way. So a lot of that is also because one of the downsides about a technical field is that things are changing all the time. Like I was saying over the break, I'm doing an iOS class, and every time I teach that, it's it's not a totally different class, but it's at least 25% different. New language, new SDK. And so a really important thing that you have to learn as a computer scientist is how to keep learning on your own. So figuring out how to find the documentation, how to transfer the knowledge that you know already into the new discipline. So that's just tough. So, but it's the way it works. So we part of doing that sort of regular work is trying to develop some of that skill along the way as well. All right, our learning objectives for the major, we have 4 components. Over the course of 4 years, if you do a major, we hope that you're going to learn how to program, how to do analysis of programs, how to understand the context in which programs are released, designed, and deployed, and also be able to draw a Christian connection between the work that you're doing and the greater world, because we very much believe, like I said at the beginning, in an integrated self, both in terms of your discipline, but also in terms of how you apply that discipline to the world. We think that both your spiritual life and your liberal arts life and your technical life should all inform each other. So that's an important thing that we try and do during our major. So those are some of our learning objectives. The tools that we use. Okay, this is also a downside of just living in the modern world. It would be nice if we had one mega tool that did everything, and Canvas tries to be that. And Canvas is really kind of a directory in my mind, pointing out to all the different things that we're using. But the truth is we're using Canvas. We are using Slack. We're using Westmont's webpage for various things. We're using the textbook. We're using YouTube Live. I don't have it on here, but we're going to be using Eclipse as well. So there's a whole portfolio of tools that we have to bring to bear in order to make the class run. And so you need to make sure that all of those are set up so that you are getting the appropriate feedback and communication from them as well, because that's what they're there for. What else to say about that? It changes a little bit. So this is the first time I'm using Slack in the class, and part of the reason Canvas has a lot of communication functions, but because we've got this remote character to the class, Slack is a little bit better for real-time back and forth, especially during a broadcast like this. So we're going to be trying to use Slack as some of that. Speaking of which, any new Slack comments from the remote peanut gallery? Nope, they still there. I wonder if are they actually watching live? Any idea? Nick's still online? Is he gone to get a cup of coffee? That's what? Yeah. Hey, people live, make a comment on Slack if you're there, so we know how much attention we should be paying to you. I guess we have to pay attention to you because you could be watching it days from now. It's sort of weird. Anyway, so announcements. The big place where I'm going to make broadcast announcements is Canvas. What was that? Someone is on? Good. Hi, James. Hi, James. So Canvas is where I'm going to put the class-wide announcements. You could do that in Slack as well, but Slack is so ephemeral, it's hard to do sort of announcements of record. So I'll be using the Canvas announcement thread. If you look on Canvas, over here on the left is the place where all those announcements show up. Canvas has a smartphone app. So if you want to use that, it can be a little bit overwhelming with all the announcements that Canvas can send you, but it does at least let you know that something has happened that you can check up on as well. Also make sure you're monitoring email if your Canvas announcements are being piped to email as well. So for example, one of the announcements that we sent out today was for the room change. And so something along those lines got gummed up. So actually, why don't we take a second here and break. And there is an assessment in Canvas for doing the Canvas profile setup. So we're going to take a moment for you to go, and I'd like you to set up your Canvas headshot so that it's a face that I can see. That helps me when I'm going through doing grading and stuff, so I don't call Tim Boaz and Boaz Tim accidentally. And also take a second to set your Canvas notifications so that at least you get announcements pushed out to you. That way, if we have some sort of late breaking change, a location change, a technology change or something, you will get notified of it. So we're going to take actually, we're going to take a 10-minute break right now. So we'll come back in 10 minutes. That'll give the people that are physically here a chance to stretch and also a chance to watch the instructional video. Canvas has a lot of really great help videos if you find some feature of it baffling. And one of them is linked in from the assessment, the one that gives you the overview. So I'll give you a chance to watch that. And we'll be back in 10 minutes. And we are live again. And let's see what we got. Face down in the bottom. Okay, welcome back. And we were just looking at Canvas there. And this is the screen we're looking at. Hey, just a couple things to point out. This to-do list, I in particular take a lot of effort to make sure that my due dates are correct in Canvas, so that when you look at this to-do list, it's a pretty good indication of what you need to be focusing on. So that should show you things that are coming up, and it's a good way to organize. And if you don't want to, you can click and get rid of them if you want. This is the student view, so I can check and see what it is that you guys see, but my instructor view is a little bit different. That's okay. Okay, so let's see. That was the Canvas work. What I would like to do now is to finish looking at our course policies here. And where were we? We were looking at announcements. Great. All right, so the next thing that we need to talk about is our schedule. No, not trash. So the calendar, like I was saying, I use that calendar a lot. So the different assignments and things in Canvas, the Canvas calendar, I try and do my best to keep that accurate and up to date. If you do notice something seems wrong, let me know so that I can attend to it. It's sometimes make a mistake and just don't update things and don't realize that I haven't done it. It's a lot of little details to make sure we get. And then I also organize it all through modules. So the modules in the upper left is how I think about the course. And so if you look at that, you're going to see the way that I'm thinking about the class in terms of progression. Okay, grading and studying. So we're trying to, this is a different format for the class. It's the first time we've done the format this way. So we're going to do a slightly different distribution of assignments. Grades are all going to be in Canvas. We're going to do a bunch of participation activities. Attendance isn't strictly required because of the remote participation, but participation is. And so all these things that we've been doing today, the quizzes and the get to know you and the Canvas updates, those are all examples of participation activities. And those are going to end up being 20% of your grade. Hopefully after today, they'll stop being so administrative and they'll be more around programming. And then I'm just going to drop 3 of those without explanation in case you miss a day or you forget to do one or something like that. That's just kind of helpful so we don't have to do too much administration around missing stuff. And then we're going to have Techni assignments. Those are multiple choice focused on the content of the particular chapters. So it's going to be very important that you read the chapters as we go along. I'll get you a better schedule of which chapters we're going to cover. We're not going to do them sequentially from this book. Based on just my experience with going through the material, we're going to jump right ahead and go right into objects pretty quickly, so we spend more time on the data structures and less time on things like arrays and items that I feel like we've seen to some degree. We'll have some programming assignments. I think we're going to have about 5 of them over the course of 5 weeks. It's a little less than we would have if it was a 10-week class, but there's just a limited amount of time to actually execute them. And then we're going to have 2 exams, and you can see that the exams, we're going to have like a midterm and a final. They will be, we'll talk about it in a second. You can see that the exams are about as much as the participation, and the exams are going to be a mix of technique questions and episteme questions as well. And if we need to change those percentages, I might alter them a little bit based on how things are going as we roll along. This class is going to be a lot of work, though. Because it's Mayterm, because we're doing 2 hours a day, because there's going to be a fair amount of reading that you're going to have to do outside of class as well. It's not going to be light, I guess. So about every hour in class, I usually say every hour in class, I expect people to spend 3 hours outside of class studying. That would be a little nuts for this class because that would mean 2 hours every day and then 6 hours afterwards. And I just don't think that's realistic. But that's usually how I structure it, so I'm going to have to be a little flexible in that regard. But certainly some of the things that you should be doing on the same day is reading the text, going over any examples we saw in class, trying your own examples along the way, getting ahead on Techni assignments or the programming assignments. So those are all some extra things, and you're going to have to do some of that work on your own as well. We're going to be learning the Java language. We're going to be learning Eclipse, which is the IDE for Java that I prefer. And we're going to be learning how to do some work with abstract data structures. And hopefully we'll get to do this drone assignment as well, which is a fun part of this class. All right, as I said, class participation is going to be primarily about doing these assessments. And so if you're in class, we'll have some time to do them. But if you're doing it the class remotely, then you can pause the video and do them as you get to it. They are due on the day that the lecture goes live, though, and that might be a problem for people that are time zone shifted. So I guess what I'll have to do is I'll have to shift it back a day. So the day on which the assessments are made live, I guess I'll have to make them due the next day just to give people around the planet a chance to actually do them. Because otherwise, I'm not exactly sure if the due dates have a time zone associated with them. They have a time, but I don't know if that's like time where you are or time in Los Angeles or, huh. You'd think, but I don't specify when I do the time what time zone I'm. Have you ever tested that? I mean, some people probably have gone to the East Coast or something, and because the browser can do things relative to where you are, so it is possible to just say 11:59 wherever you are. What's that? Yeah, Flo. When you're out there, tell us what the due dates are. Are they in Los Angeles time or are they in South Africa time? Sort of crazy. In any event, I'm going to add 24 hours to him just to deal with that problem, regardless. Yeah, you can stand in New Zealand and like jump back and forth over the date line or something. Okay, so 3 of those will be dropped automatically. That's great. Attendance is not part of your grade. Can't do that, but participation is. So the work that we talk about in class obviously is part of what you're responsible for. So even though attendance isn't required, going over the material is super important. So you need to make sure you know the material from class, from these lectures, as well as the assigned readings along the way. And let's see. All right, so I have this idea of education that's based on something called the trivium, which has 3 components to it. Different sources talk about the 3 different ways of learning, but basically it's this idea of memorization or learning a real skill. It's like learning grammar and syntax, and so for me that maps to Techne assignments. Then there's a second higher level component, which is synthesis, which is the process of using these skills to actually do something new. And then there's a highest level bit called rhetoric, which is where you argue for new positions or your own positions on different things. That would be, for example, kind of formulating a new language or something like that. So Techne assignments are supposed to be in the weeds, details, memorization, stuff like that. And so those are going to be multiple choice exams. You guys are all familiar with that from CS-10. Did everyone here take CS-10 with me? Yeah, Tim, you did, but a different semester? Yeah. Okay. So you guys are familiar with this. And it's a way to help you process the homework reading as well. The episteme or the programming, you guys are also familiar with the programming as well. They're similar. You'll do some coding and turn it in on Canvas. Exams, we're going to have 2 exams. They're going to be like the exams you've seen, mostly multiple choice, some short answer. They will be in class. For the folks that are remote, we're going to be using a service that does remote proctoring of exams. And so in order to do that, you're going to have to connect with the service. We'll get more details for that in the future. And basically what happens is the service takes over your webcam and you take the exam in front of the webcam and they sort of surveil you while you're taking the exam. And it's like being an SAT or something. And then they report whether or not they saw you the entire time, whether or not there were any glitches or anything. And then you turn in the results of the exam, and I'll have to check to see if I feel like there's paper involved, but that seems awkward too. So we'll have to look into that a little bit more. So logistically, a lot easier if you're in person, but we're going to figure out how to do it remotely. This, by the way, is an experiment for Westmont. We've never done a hybrid class like this, so some of the things that we're doing is specifically to build some best practices on how to pull this stuff together. So in my mind, the exams is like that piece of rhetoric, kind of doing bringing all those different things of skills and practice together. Yeah, please. They are written if you're in person. If you're remote, they're going to be the same, but I'm not exactly sure how they're going to end up being delivered. There's a method that the remote proctoring services use, and it might be that they have their own website where they show you a scanned version of the paper thing, and then I don't know if you do it on paper, you take a picture of it. I'm not exactly I've read it before, but I've read several of them, and they have different approaches to it. So basically, though, it's going to be on paper, that style, even if you are actually doing it digitally. All right, for late penalties are my standard penalty, which is 1% per hour after the due date. So you can it's sort of a smooth fall off. So if you feel like it's midnight and you can finish the exam in an hour, it's probably worth it because that's just 1% off. 0 versus 99 is a pretty good trade-off. Somewhere around 10 or 12 hours after the due date, you start to hit the point where you're not making sufficient progress, and you might just want to cut bait, turn it in. So, but it's soft so that you guys can decide how you want to handle it. All right, during class. So this is usually this is where I try and talk about technology use in class. Technology use in a history class or in an English class is one thing. It's kind of clearly distracting and difficult. But in this class, we're going to be using our computers. And so it's super hard to come up with a way of imposing some kind of discipline on you guys. And so really it's up to you to make sure that while you're in class, you're making the most of it. It's easy to allow notifications and instant messaging and everything else to distract you. And it just turns out that we're just really bad at multitasking. We think we're good at it, but we're actually not really absorbing very much material when we try and multitask. And unfortunately, boredom is really helpful at trying to absorb material. And it's awful because it feels boring. But it's like in the process of actually taking paper notes, it's in the process of sitting there and not having things distract you that things really cement. So it's just a good practice for the world that we live in to figure out how to manage your notifications and to manage your distractions along the way in order to try and put your limited attention on the things that you want attention put on. Because if you just allow your attention to be taken by anything, there are plenty of things that will take it from you. And it's kind of it's interesting because people have, I think it's Herb Simon who says that what information consumes is attention. And we have so much information and it's consuming our attention. And there's an opportunity cost. When you're paying attention to one thing, you're not paying attention to another thing. So as a mental discipline, being able to choose what it is that you're paying attention to is a super big skill for adulting. So a lot of this paragraph here is about how that happens in the class, and but because we're a technology class, it's up to you guys to do it. Just let you make that decision. Faith and learning. I don't have a super structured way of doing this. I tend to feel, I guess, led by the Holy Spirit in different contexts for what seems appropriate to address, given how we're working together as a group, sometimes how things are happening in the public sphere. And so periodically we'll do things, we'll open in prayer, we'll talk about something related to faith and learning. Usually we don't record that, but here we are, new world, so maybe we will record that this time. Take it from there. Email. Email's a disaster for me. By the end of the semester, it's so overwhelming that it's very difficult for me to work with email. If you do want to email me, my goal is to respond within 24 hours. It really helps if you put CS-030 in little brackets, like right here, in the header of your email, because then I can pick it out really quickly. One way that helps make one thing that you can do to help manage email better is to do groups of tasks all at once. So if I see CS-030 and I'm in the mode where I'm doing class response, I can go through and pick out all the class issues really quickly, and that helps me to do that. The other thing that helps me is if you communicate via Canvas, because then when I drop into Canvas, I've got all the class issues right there, and I'm not dealing with my cable bill and the dog and the people that are visiting in 3 weeks. I'm just sort of focused on the task. So that helps me to do it. That might be also something that's useful for you guys to develop as a discipline, trying to group your activities together so that you get less transition time wasted in moving between tasks. And then just here's a note and a little link out to some etiquette about email. Email is something that I grew up with as a pretty formal way of communicating. You guys grew up in a world where primarily, probably until college, you were communicating via text messaging and maybe Snapchat. And that email just stereotypically is not something that you usually interact with until you get into a college environment or into a work environment. So learning how older people who have experienced email for a long time expect communication to happen in email is a good job skill, as well as it's like how you would write a letter to someone. For me, handwriting a letter is a skill that I didn't really grow up with and had to learn. Writing checks, something like that. So the main thing is to remember that people who receive emails are thinking of it a little bit more formally than a text message. So use a greeting, open with some sort of, how is it going? Thank you for your lecture, whatever, who you're talking to. It doesn't have to be me. And then ask your question. And then a good thing to do is at the end, after you describe your situation, write down specifically what you hope will happen at the end of the email. So if you would like something regraded, say, a good example would be Professor Patterson. Hey, thanks for that lecture on generics. That was I found that really interesting. During that lecture, we had an assessment, and I think that it got graded wrong. Could you please take a look at my assessment and double check that question 3 was graded correctly? That would be a good example of an email that doesn't annoy a professor because it's clear what you're talking about. It's adequately formal, and it's just structured well. So, and that's more about expectation than it being the right thing or something like that. Okay, yeah, boys.
So if we send it to you through Canvas, do you still want us to put CS-030?
No. Yeah, because if you send it to me through Canvas, Canvas puts its own thing on it for me. Yeah. Right here, there's an inbox, and that's for. So the things in the blue here are things that are like higher than each individual class, and then these are things that are just for the individual class. Yeah. So, yeah, when you compose it, it specifies. You type in who you want it to go to. It's just email. It's just email within Canvas. No. No, it's just internal to Canvas. Yeah, because it doesn't go in or out. Like it's just within Canvas as well. Usual sick policy is that if you go to campus, does campus have health services during Mayterm? You know? Seems like they must have something. Let's do it. Okay. If you do end up being sick and can't make it to class, the usual way in which we handle that now is you email, and you saw the doctor, you email me, and I think Claire works at the front desk, and you just email me and say, hey, I wasn't able to make it, using the formal thing, right? Dr. Patterson, how's your day? Hope everything's good. I wasn't able to make it to class today. I've CC'd Claire on this email to let you know that I saw the doctor. Because she won't tell me because of privacy concerns, and you don't have to tell me why you were there, but what she'll do is if you didn't actually go to the doctor, she'll say, whoa, Tim, you're totally off base. You did not show up. But if you do that, then I can help to figure out how we're going to respond with respect to participation and assessment. Yeah, Lisa. Great. Oh, got it. Okay. Hi, Wayne. I guess Wayne's watching. Repeat the questions from the room. Okay, so let's see. One question was, how do you do email in Canvas? And we went through that. And then did someone else ask one that I forgot to repeat? Okay, I will remember to repeat them. Nick says hi. Hello, Nick. How are you? All right, incompletes are an extension of turning in work. These are rare, and usually it has to do with some kind of medical emergency. Someone breaks a leg or something. And so if that happens, then we give people an incomplete and have the ability to turn in stuff late rather than failing a class. Usually I only use those for unforeseen emergencies, and they're rare. Academic honesty, this is sort of the awful, it used to be the worst part of my syllabus. We have now a worser part of the syllabus. The bottom line is I always have people who are struggling with understanding what an appropriate way to collaborate is in computer science courses. That's partially because of a struggle just understanding how to collaborate generally, but it's also because computer science is unique in the way in which you can collaborate. It's really easy to cut and paste code from Stack Overflow, and it's not clear that that's wrong because that's what happens in the real world. And so it's just a careful evaluation and reflection on what you're doing. And the bottom line is, does the work that you are submitting accurately reflect your understanding of what's happening? And that's sort of the principle, but the specifics are, don't plagiarize. If you find yourself cutting and pasting code, make sure you're citing it. At the very least, that's going to keep you out of a whole boatload of trouble. It might not mean that you completed the assignment okay, but the difference between copying someone's work and saying where you got it from is really enormous in academia. So I'll let you read that if you want. I don't want to dwell too long on it. I feel like we're going long on the syllabus here. I guess the one thing is I have had a lot of problems with cheating over the years, and so please take it seriously. I'd rather not have to deal with it. Okay, so some guidelines for how to work together appropriately. I encourage you to work together. Working together is a great way to learn. It's a great way to get unstuck. Usually, if you're stuck in computer science for more than 2 or 3 minutes, it's just not going to take no amount of head banging against the wall is going to fix that. You really need to get some kind of outside help from a peer, from a tutor, from the web, something like that. So, so how do we work together? So just a few guidelines about when working together has gone badly. All right, so working together has crossed over into something that is inappropriate when you find yourself taking a photo of someone else's work. Okay, so if you find yourself taking a picture of someone else's code, you're starting to go into an area which is now like copying or plagiarizing. And that has these knock-on effects that are really difficult for me to manage, especially when that photo starts circulating around. That becomes a problem. If you find yourself just cutting and pasting code, that's usually an indication that something is going wrong with your learning process. At the very least, if you're going to work with code from Stack Overflow, take the time to type it in manually, because just like taking notes manually, that typing, you slow down and you think about what you're doing, you get the syntax right, it's helpful. And then finally, if you find yourself transcribing code from someone else's screen or whiteboard, that's probably a problem as well, because that means that you didn't actually do the work of constructing the code, you're just taking it from someone else. So I just provide those as 3 examples of things that you can keep in your mind as lines that you should just be aware of, that if you're doing that, you're not collaborating appropriately. And the exception to that would be if you're doing pair programming. So I have this note here that said you should rarely, if ever, be touching someone else's computer unless you're doing pair programming. Pair programming is very different. That's where 2 people are working to produce the same thing together. And so in that case, there should be very detailed talking and so on and so forth. Any questions about that? Like, this is the depressing part. Okay, go ahead. Okay, so the question is, are we still using Saros and Eclipse? We're going to try. I'm not 100% sure if that's going to work out, but we're going to try. My office hours are by appointment until I can get my act together, because the transition from the regular school year to Mayterm is really rough, and so I've got a class at 10:15 and then one at 3:15. I gotta get things ironed out before I can set something down regularly. All right, academic accommodation. This refers to the fact that we have a very helpful disability services center here that helps us to take care of people's various disabilities in different ways, and I want to support that. So if you take advantage of those services, if you feel like you need those services, coordinate through Sherry Noble. And what she does is she just makes sure that policies are applied equally across campus so that we can be sure that we're treating everyone fairly in terms of equal disabilities are respected equally. Overall, though, like, I want you to succeed. So we'll do whatever we need to do to make sure that we can accommodate your concerns. The goal is for you to learn something, not to, enforce some weird policy. So that's a goal. We'll figure out a way to meet the requirements of the course. in a way that's fair to, like that principle, fair to me, but also fair to everyone else in the class and fair to you. All right, and then I used to say that those were the worst parts of my syllabus, but now we have the emergencies page. And the emergencies page is about anticipating the unthinkable, classroom best practices. So there are these 4 things that unfortunately we deal with now in the modern world. And so this is a moment to think about the physical space that we're in. Our remote participants can think about their own space while we do this. But so a couple things to note about the space we're in, that we don't have an exit except for there. So we have a room we can run into. That's a server room, but it's a dead end. But we could hide there if we had an intruder of some kind. We have this mnemonic that's evade, barricade, or overwhelm. That means that if you can get away, get away. If you can't, barricade the door. And if you can't do either of those things, attack. So, hoorah, I'm ready to attack. We're pretty good about barricading, so because we got those file cabinets right by the door if we need to. So that's our main escape route. What we can do though is if something is going crazy, we can get up against that wall so no one can see in here, and we'll just shut off all the lights as soon as we can, so it looks like it's an empty room, and lock the door, of course. It would be great if you could throw your shoes. The other thing I'm going to do, it's down here on the bottom, is if we do have something happen, I'm just going to turn this computer around so that it's all being broadcast. So not for entertainment, but for like forensics, right? So we know what's going on, possibly for intel. Earthquake, jump on, get under the tables. Those are pretty good. We have we have an exit. If you go left out this way, you go to the bottom of the stairwell from the loading dock, and so you don't have to go out at the middle stairs. You can go this way. Of course, you can go up the middle stairs. There's also an exit on the far right backside without going up any stairs as well. 2 in front, middle, over the way. Yeah. Wildfire, we know that. We go to the gym if we need to, and then if there's a building fire, well, we just get out of the building if we can. So that's the main thing. And we know from experience that this is something that we have to deal with. Although, yeah, we'll see. Hopefully, it won't happen again. Yeah, we don't have. That's right. I don't have a mudslide policy. I need to get my mudslide policy ready to go. So this is. I think this is behind Paige. Or is that? I don't. You guys recognize that probably.
That's not behind Paige.
Maybe Clark.
Maybe.
This was filmed by the firefighter last December.
Right. It looks like it's up on the. So there's like Paige and Emerson.
Uh-huh.
And then there's like the trail and there's those houses up there.
We've got the little. It's got the little like Westmont knock 'em over lights there. Uh-huh. We really got to get a better light solution. Okay, great. So that is the end of the syllabus. So that's super. So what I would like to do now is to take 5 minutes. We will do an assessment. We'll go offline briefly so that you can do the course policy quiz. This is a quiz to give you a chance to go back and make sure you understood what we talked about. This quiz in particular, if you get anything wrong, you can go back and adjust. All right, so we'll take 5 minutes, give you a chance to do it once. Local people can take a break if they need to, and then we'll come back and pick up. And I think the next thing that we're going to do is we're going to take a high-level look at Java, and then we're going to jump into Eclipse for as much time as we have remaining. Okay, so see you in 5. Test, test, test. Okay, we're coming back online. Into overhead. Get my face in there. Hello. And okay, so we're shifting gears now into a little bit more technical and less administrative stuff. And so the first thing I want to show you is just a graph that's a little bit dated about computing power, just get you thinking a little bit. So this just gives you a little bit of a history of the computing power of different computers over time. So along the x-axis down there, you can see year starting at 1900 and coming up to about 2020. And on this graph, you can see red dots for different specific computers, models of computers. And the y-axis is the millions of instructions per second per $1,000 that each one of those machines could execute. And the y-axis is on a logarithmic scale. And so the growth, by virtue of being approximately linear, is actually an exponential graph. So if it weren't a log scale on the y-axis, it would be an exponential curve. And what we can see here is we can see that the computing power has been growing basically exponentially. And so this is, you might have heard it called Moore's Law before. Moore's Law was developed by Gordon Moore, who at the time was, or eventually became, the CEO of Intel for a period of time. And he recognized that the computing power of computers was doubling about every 18 months or so. And there wasn't anything that was fundamental or scientific about that law. It was just an observation that turned out to hold true for much longer than anyone thought was possible. And you can see that this only takes us up until about the late 1990s. I couldn't find a good graph that extended these numbers along the way. But it's also interesting to see the complexity of what can be calculated along the y-axis on the right side. And so you can see down there in manual calculation, what that means is that it was about the 1940s and before, computers were operating slower than manual calculations. And sometime around the 1940s to the 1960s, manual calculation was surpassed by some of the large computers. So if any of you have seen the movie Hidden Figures, that movie was about the point at which computing went from being feasible to went from humans doing it. So the women in Hidden Figures were the humans that were doing the calculations, and their job was taken over by computers. What's interesting about that is the women who were doing the calculations early on were actually called computers. So women were the first computers. They were doing the manual calculations. And so when the computers came in and started doing the work that the women had been doing already, the women took over the title, the computers took over the title that the women had. And so we started calling these things computers because they were doing the work of the human computers before them. And so the very first computer scientists were all women because they were the people whose jobs were being displaced and who saw the opportunity to take over the functioning and the administration of those computers. And so the Hidden Figures movie is a nice story that shows that transition along the way. You can see that there's some organisms along the y-axis as well. And so about 1990, we had about the equivalent computing power as a spider. And it could easily be suggested that we have about the same computing capacity as a human now, but that assumes that computers and human brains operate the same way, which is clearly not true. And so this has something to do with the relationship between the numbers of transistors and the number of neurons. Yeah, Tim.
Is that what we're doing? Well,
You mean the graph? No, the graph is, I'm talking about what the computer is able to do regardless of the number of transistors. So different computer architectures can do more or less with more or less transistors. So the graph is really showing how much work the computer could do regardless of its architecture. And the right side is just trying to find some kind of equivalence. But, you can't really say how many instructions can a mouse do per $1,000. It doesn't make sense along the same scale, but it's just an approximation of the complexity of the different organisms on the right side. But it's thought-provoking, right? And so if you have a computer that can do about the same number of calculations as the human brain can do, that's different than manual calculation, right? Manual calculation is a person doing it by hand. The human brain is about the calculations that are going on inside our head. So it really does call into question, well, if computers have that capacity, then why aren't computers the same as humans now? And it has something to do with the fact that humans and computers are doing different things, at least at the architectures we have today. Okay, so for this class, we're going to use some tools. One of them is Eclipse, and so in the announcement that I sent out, I gave you a link to download and install Eclipse. Eclipse is cross-platform, so you can use it on Linux or Mac or Windows. The current version is called Oxygen. It's going by it's using first letters, so it was M and then N and now O, so it's Mars and then Neon and Oxygen. So Oxygen is the current one you want to install. We're going to see if Saros makes sense for us, but Saros is a real-time collaborative editor for Eclipse. And so what it does is it does what Google Docs does for word processing. So in Google Docs, multiple people can write a document at the same time. Saros enables people to work on code at the same time within the same document. So we'll look at that. We'll try and install that, and maybe these instructions here on this slide. I know that Lisa, you were having trouble installing. I think you were having trouble installing it. Probably some others of you as well. So this slide gives you more specific information about this. The other thing is that it says on the slide here which server to use is not clear, and I give you an example of one. Since I made this slide, I've set up my own server here on campus, and so Saros is only going to work for people that are within Westmont's firewall. So if you are remote, don't bother trying to set up Saros. Saros is a real-time collaboration tool anyway, so if you're not live, it doesn't make sense to actually work with Saros. So Saros is really only going to be a tool that we're going to use in the classroom, although on the recording, people are going to be able to see us all working together, but I think that's still instructive. So I'll get you better instructions about the URL to use for the collaboration server for Saros. This is that server is the place where all the messages about who's doing what editing, it's the clearinghouse for those messages. Vital Source, this was the thing I was talking about, Tim, with the online textbook viewer. It is, I'm not sure how you get it. Somehow I got it along the way, and somehow you get a code to download the book, and so you can work with the publisher or check to see if there's something on the inside cover or something. Boaz, did you ever get that working?
I never did.
Okay. I actually have never seen a student working with it through Vital Source. Sometimes they get it through China or Kindle or something, but is that from the publisher or from some other organization? So it's possible to rent it as an e-textbook. Are you on the college bookstore website? On the Vital Source website? Okay, so apparently if you go to the Vital Source website, you can rent it as an e-text. Yeah, it's a pretty good book. I mean, in terms of a reference for Java, it's probably something that's worthwhile having. Yeah, it's not unusual for publishers to sell you the paper version and then give you access to the digital version for $1 or $2 or something, sometimes free. Okay, so when we are doing our work, we may encounter compile time errors in Eclipse. We'll talk more about this. Two types of errors that these are going to show up in our chapter 1 reading. Compile time errors are errors that Eclipse is able to identify before you run the program. Usually it's because you've done something wrong with the syntax of the language. Runtime errors occur because of logic errors, so things that are wrong because of their intention. For example, you do the wrong math to calculate miles per gallon or something. That's not a compile error, syntax error, that's a logic error because you used valid math to compute the wrong answer. And so there are two categories of errors that we're going to deal with. Java has really strong compile time error checking because it's basically a strongly typed language. There's some argument in the academic community about what a strongly typed language actually means, but Java certainly has stronger typing, which means that Eclipse can do more work for us to help us to find those errors before we've run our program. To help us catch runtime errors or errors in our logic, we're going to do something called unit testing. And this is a strategy for identifying runtime errors before our program gets out into the wild. And so we'll learn how to do those. One of the ways in which the book describes Java is it says that it is a safe language. I think that a lot of people would take issue with this because there have been some pretty serious security flaws in Java recently. But by design, it's supposed to be safe. And so the kinds of errors that we find in Java tend to be implementation issues, that it is designed to be safe, but it may not be implemented very safely. So what do I mean by that? There are some examples of people writing programs that hackers, malicious hackers can run those programs in ways that give them access to your computer because of a flaw in the Java language. And those get fixed occasionally. But that is actually why you don't see Java. Java has been removed from browsers. So like if you have a Java program, it used to be that you could run it in a browser. But because of these repeated errors in the implementation of Java, most browsers have removed the ability to run Java in them. So Chrome certainly has, I think Firefox has now, and maybe Safari as well. So what that means is that Java is different than JavaScript. Java is a language that runs programs that run on servers, that run on your laptops. It is very different than JavaScript, even though they share the same first four letters. JavaScript is a completely different language. So Java, for the most part, is used on servers. It is the language of choice for Android. If you program on Android phones, it's the language that's used there. And Oracle, the company that is behind Java, is trying to get it to be used for more front-end user interface designs. They've just released some new libraries that are supposed to make it work. It's kind of a shame because I really like Java. I think Java is a really great language. It's really powerful. I think it's very well structured. I can tell it was made by academics because everything's sort of obsessively, compulsively correct. But unfortunately, the graphics are just awful. So like working with the user interfaces, etc., are just really bad. And that sort of has limited its uptake, I think. One other thing from the book's discussion today is talking about an algorithm being terminating. The fact that an algorithm is terminating is a little bit of a nuanced explanation. When we talk about algorithms being terminating, it means that it's terminating in a formal sense. There are lots of algorithms that don't terminate. For example, Microsoft Word. Microsoft Word never stops waiting for you to type stuff in, and we still talk about that as being a terminating algorithm because you never type something in and get the wheel of doom forever unless it's a bug. Right? So terminating is a term that we use to describe whether or not some calculation comes to an end, not whether or not a program comes to an end. So the basic understanding, the basic vocabulary that we use is that algorithms must terminate in order to be valid algorithms. Okay, a couple other terminologies that we need to know before we jump into Eclipse. How are we doing on time? We'll probably just load it up for today. Eclipse is a program, an integrated development environment, an IDE. It is like Spider for those of you who were in CS-10. It is like Xcode for those of you that program on iOS. It's like Visual Studio if you do programming in Microsoft. It's its own environment that supports programming. It is open source. It is available for free. It, however, needs a Java runtime environment in order to run your programs. So it's one thing to write the program, it's another thing to run the program. And so in order to run the program, you need a Java runtime environment. That's like downloading Java. What you're getting is you're downloading the Java runtime environment. And the other thing that you need is a Java development kit so that you can write your own programs. So the JRE enables you to run Java programs. The JDK enables you to write your programs. In the link for the announcement for today, I gave you a link to Oracle's download for Java. I think I gave you the link for 1.10, Java 10. Sometimes we say 10, sometimes we say 1.10. Those are the same things. Java 10 just came out a couple weeks ago. So that's an update. You might see a couple different editions there. You just want the J2 SE, the standard edition. All right, so without further ado, let's fire up Eclipse and take a look at that. Let's see, give me some space here. And you guys can bring up Eclipse as well. What we'll do is in the last few minutes, we will just give you a rundown of Eclipse. Here's the splash screen. and we'll do a Hello World program as the first thing for our next class. You'll see that there is an assessment today for doing the Hello World program. We'll push it off to the next class. When you first launch Eclipse, if you've launched it before, you're going to see this window here. It asks you to pick a particular directory on your hard drive where you're going to be storing all of your files. And what you can see here is that I have a workspace set up for the last class, but I'm going to go ahead and create a new workspace in the directory that I have for this class. You should also find a place on your computer where you want to store all the programs for your class. So here's this class. I am going to create a new folder called Workspace. This folder on your computer is going to hold all of your source code. So you have to know where you're putting it, and you're going to have to remember where you're putting it. If it's the first time you've launched Eclipse, you're going to get something that looks like a big white screen, and there should be like an arrow that looks like it's turning a page or something. And if you click on that, it should start this process that you're seeing on the screen right now. Once you've identified a workspace, you can go ahead and launch, and you'll get the basic window from which your Eclipse work will start from. Oh, no, here it is. Great. So I got my order wrong. This is like a splash screen. I'm going to uncheck this. Always show welcome at startup. I don't want the welcome screen, so get rid of that. And then this button here, this workbench button, is the one that I really want to get to. And once you get there, you get into your working environment. So now this is the basic development environment that we are working in. You should see more or less the same thing. Boaz is on Saros, so that's great. You should see more or less this window. You might not see that Saros plugin down here at the bottom if you haven't installed that yet. Eventually, this window over on the left side is going to fill up with files that we're working on, and this window in the center is going to be the place where we type our code, and over here on the right are different kinds of utilities. So the last thing that I would encourage you to do before we quit for today is to come over here where you've got this little window with the plus sign, open a new perspective. And what this means is we're going to open an environment, and we want the debug perspective. We're going to open that. Once we open it, it's going to show up over on the taskbar here and be available to us. And you can switch back and forth between the Java development perspective and the debug perspective. All you're doing is choosing different layouts of windows when you do that. But by default, there are two different setups here. One that's convenient for debugging your program, and one that's convenient for just running your program. So if you can get those two things working, that's a good place to stop for today. We'll give our remote folks one last chance to ask any questions if they have on Slack. You guys can alert me if you see anything. That's correct. As soon as I'm done with class, you'll find that I've changed the due date for the Hello World assessment so that it's due tomorrow instead of today, because we ran out of time to do that. Tomorrow, it'll be, well, what I'll do is I'll put it in the module for accomplishment tomorrow. The actual due date will have a 24-hour delay so that folks in South Africa can catch up. Although they're ahead of us, but they won't have the lecture. So okay, any last questions before we terminate? Metaphorically? Okay, people out there on the internet, thank you for tuning in. Appreciate your attention. We will see you tomorrow, same time, same bat channel. If you have any questions, bring them up in Canvas or in Slack. Going once, going twice. All right, so long.